Hi students, how are you? How's everything going? How's online learning? I hope you're having a productive experience with it. There's a lot of advantages to online learning. So yesterday we were learning about significant figures. Maybe you didn't know what the word significant meant, so you looked it up real quickly on Google or on Bing. Did you do that? Well, this is the opportunities that you now have with online learning. You can pause the video, look up things, learn some new vocabulary. Maybe you know what significant means, but you don't understand the concept of significant figures and you wanted the definition. You could have looked that up. Maybe you weren't happy with the definition that's online. Well, there's probably like 5 or 6 places that have it defined in slightly different ways, so you can read a couple definitions. You can read all the definitions. But what I'm saying is online learning offers a lot of unique opportunities. You don't have to be stuck, at least you don't have to be stuck for long. You can use the power of the internet to look up answers, and find the level of meaning that you want. If you want to understand something very deeply, please feel free to do that. If you just want to have a basic understanding, the internet offers that as well. So please take advantage of this unique opportunity to be learning online. Okay, ready for the opening and the 5-minute lesson. All right, well, let's begin. Okay, here is today's opening. Please pause the video and solve the problem, writing your answer with correct significant figures. Please pause the video now. Okay, you're back. Does that mean that you have the answer? Hopefully you've written it down. Okay, 374 times 12, I use my calculator and I get the answer 4,488. That is mathematically correct, but in the world of chemistry, we are concerned with significant figures. So how do we reduce that? Well, our first number, 374, has 3 significant figures, but our next number only has 2 significant figures. The number 12 has 2 significant figures. So that means our answer must be in 2 significant figures. So I'm going to keep the 4, and get rid of the rest. Because the next digit is an 8, I'm going to round up, and this is going to become 4,500. There is the correct answer. Did you have that correct at home? Well, I hope you did. If you didn't know how to solve that, you need to watch the videos I recommended yesterday. Tyler DeWitt has an introduction to significant figures, part 1 and part 2, and you are required to watch that. All right, well, today's lesson is significant figures. What are significant figures? Significant figures of a number are digits that carry meaning. They communicate the precision of measurement. So here are 4 measurements. The first one is 12 grams. Well, we know the last digit's always an estimate, so it could be 11 grams, it could be 13 grams, maybe even 14 grams. But the next one is 12.3 grams. That means I definitely have 12 grams and a little bit more. Maybe it's 12.2 grams, maybe it's 12.4 grams. But the one thing I am certain about, if you need 12 grams, I have at least that much. The next one looks really precise, 12.34 grams. Someone took some accurate measurements and communicated that they're not using the triple beam balances at a high school. They're using a more precise scale than that. And they were able to get 12.3 grams, certainly correct, and about 4/100ths of a gram would be the estimate. And then look at this next number, 12.345678 grams. This is grams to the millionth of a gram, and all those digits are significant, but we'd consider the 8 an estimate. Now, an estimate's still significant. That's still important. It looks like we have, close to 12.34568 grams. So that 8 is important, but it should also be recognized as an estimate. So all of these digits are significant digits, but the last one is an estimate. So a famous celebrity just bought a house in Atlanta for $1 million. Oh, there it is. That's a nice house. And, you know, when someone says that, do they really mean $1 million? When someone says something cost $1 million, well, actually, the house was $994,378.54. So does that mean the person who's told me $1 million was lying? No, it just means that the person was estimating. And we do that kind of thing all the time. We don't want to ramble on with all the digits that you don't need. We can just say it was $1 million and we recognize that as an estimate. But in the world of chemistry, you have a responsibility to communicate very clearly. So let's say the house really did cost exactly $1 million and I wanted to communicate that. They got the house for exactly $1 million. So what would I do? There is the answer right there. Do you see it? The decimal at the end indicates all of the zeros are significant and true. So before we had the number 1 million, and it just had one significant figure. That one was significant, and the rest of the zeros were considered estimates because that's what human beings do. But if you ever want to communicate something is exactly $1 million, put a period at the end of it, and that period is a signal. It indicates that the zeros are not estimates in this particular time. When I say $1 million, I don't mean 990,000. I mean exactly $1 million. That's why you put a period at the end of those numbers. So these are the measurements from yesterday's opening. 10 grams has one significant figure. So that means the zero is an estimate. It could actually be 11 grams, could actually be 9 grams. That can be pretty frustrating. But when someone puts the period there, that means they know that it's very close to 10 grams, that there's two significant figures. The one is significant and the zero is a very close estimate. Here's 10.0 grams. There's three significant figures. If you need 10 grams, we definitely have it. And to the 10th place, that's an estimate. And then the next one is a really accurate measurement, 10 grams estimated to a 1/1,000,000th of a gram. If you have a really expensive scale, those are very rare. But if you are going to take a measurement that accurate, and it's just very, very close to 10 grams according to that scale, you do want to be able to communicate that. And this is the way you do it, by showing the significant zeros. All right, let's look at some sample problems. If you watched Tyler DeWitt yesterday, you know how to do a multiplication problem like this. There's a 3 significant digit number multiplied by a 2-digit significant number, and we get the answer of 7,685. And 53 only has 2 significant figures, so the answer must be limited to 2 significant figures. So the answer becomes 7,600. Actually, that should be 7,700 because we round up. Oh, a little mistake there. I'm glad I caught it. Hope you did too. All right, here's another sample problem. What is 25 times 4? In the normal mathematical universe, the answer would be 100. 4 has one significant figure, so the answer must only have one significant figure, which it does. That one works really nicely. You don't put a period at the end because then it would have 3 significant figures. So the answer is not 100 period. The answer is just 100. In that case, the 1 is significant, the 2 zeros are insignificant. We'll learn a little bit more about that later. What is 1,250 times 4,040? Do you see the trick there? 1,250 has a period. That means it has 4 significant figures. The 0 is significant. And 4,040 has a period, so that means that has 4 significant figures. So let's pause the video and see if you can puzzle out the solution. This one involves a trick. So pause the video, work it out, see if you can write that one with 4 significant digits. Kind of a trick question. Let's see if you can do it. Pause the video now, please. All right, we're back. Did you do it? Did you have trouble with it? There is a trick to it. It is possible. You might have wrote down that it's impossible to do, but actually there is a way to do it. Let me show you the trick. What is 1,250 times 4,040? Well, if I put it in a calculator, I get 5,050,000. which has 3 significant figures. Now I can put a period at the end, but then I'd have 7 significant figures. I want 4 significant figures only. How do I do it? You do it by this. You do it in scientific notation. 5.050 times 10 to the 6th. That's one of the other reasons we use scientific notation. It's a way, sometimes the only way, to represent certain numbers in proper significant figures. That is my lesson on significant figures. Hope you enjoyed it. The end.